So if we're converting from rectangular complex to polar complex, what do we think about when we're thinking polar? What two things do we need? R and theta. All right, so in the end, it's a polar complex number. So if you look at your unit circle, it looks like this. There's our formula. Okay, right here is where we're going to plug in R. Right here, we're going to plug in theta. We've got 5 and 5i. Which one of those two things, what does 5 and 5i stand for? X and Y. This is your X. This is your Y. We're going to convert to polar. So which formula are we using to get our R value? Because we need that. Pythagorean theorem, yep. X squared plus Y squared equals R squared. We're going to find that and then plug it in there. And then we're also going to use tangent of theta equals Y over X and find that and plug it in there. Go ahead and try that. So we set it up correctly. Now it's just a matter of doing it. So we plugged in 5 squared plus 5 squared for my X and my Y. So it's 25 plus 25. That's 50, but that's what R squared is. So I need to square root that. Well, I can't break down 50 evenly, so I'm going to break it into 5 and 10, and 10 into 5 and 2. So when I write my radical, my R, there's my pair, so that goes on the outside. What doesn't have a pair goes back on the inside. So my radius is 5 radical 2. Then I'm doing tangent. Tangent of theta is Y over X. So that is 5 over 5, which is 1. So you're going to your unit circle, and you're looking up where tangent is 1. It's at 45 degrees and 225. Jarrett, why do you want 45 and not 225? Both the X and the Y at 45 degrees are positive, just like our X and our Y. That's our answer. It needs to be in that form down there. Questions there? All right. So remember, if we're multiplying, it's really easy to find ZW. All we're doing is taking the two radiuses and multiplying them together. So 6 times 3 is 18. And then it's cosine of our angles. What are we supposed to do with our angles when we're multiplying? We add them. So 280 plus 350 gets you 630. Plus I sine 630, which is a completely reasonable answer. The only problem is if it's a multiple choice test, that won't be one of your choices. What do we need to do to make 360 fit on our unit circle? Oh my gosh, I just said it out loud. Subtract 360. Yep, we all knew. Subtract 360. So your final answer would have been 270 there. So we're looking at this equation here, trying to decide what type of graph it is. Since these two numbers are the same, that's going to be a cardioid. Remember the word cardioid, you think cardiac, like a heart, and so it does kind of look like a heart. It's going to be on its side actually here if you use your graphing calculator. It looks something like that, only less ugly. The symmetry is x-axis. Jose, why is it x-axis? Because it's cosine, and then we're doing a maximum. Aaliyah, what do you think our maximum was here? 12, because she was thinking to herself, what could she plug in for cosine to make this work? What number did you plug in? She plugged in 1 and not -1. So that means she's going to her unit circle and looking for where cosine is 1. Dimitri, where is cosine 1? That's at 0 degrees. There gives me my answer. So this is writing alternate coordinates. Here is the point 360. I wanted one with a negative radius. When you have a negative radius, Justin, what does that do to my point? Not straight down, straight across. So if it's 60, it's like I walked 1, 2, 3 this way. So if I have a -3 radius, that means I'm going to walk 3 in the opposite direction. Which angle am I going to? 240. Okay, that one you guys were good with. It's the second one, and it was just a silly thing that we forget. 3, and then I want a negative angle. If you have a negative angle, Dimitri, what's that going to do? Flip it which way? Up and down. So if it was at 60, which angle is that going to match with? 300. But you can't write 3 comma 300. It's 3 comma -300 because we flipped down. And so you need to make sure you have the negative sign. That's what both of you did. You just got to put that negative sign in there. Convert from polar to rectangular complex. This is always one that seems way harder than it actually is. If we're going to rectangular complex, that's in this form. Z equals x plus yi. The easy thing about this is it's already set up for you because it already says cosine of 180. What happens when you take cosine of 180? When you go to 180, what are you looking for? The x. What are you doing when you're looking at sine? You're finding your y. The only thing is, when you get done, you multiply by 6. You find your x, cosine of 180 times 6, plug it in. Sine of 180 times 6, plug it in. So when we're plugging this in, we're doing cosine of 180 times 6. So we look at our unit circle, Justin. What's cosine of 180 going to get me? -1, and I'm multiplying that by the 6 in front. So what's my x going to be? -6. And then I'm doing my y. Okay, so if I'm doing my y here, Naomi, what is sine of 180? 0. And then I'm multiplying 6 times 0. That's 0. So this is fine. What a lot of students will do is they'll try to tell me this because you don't have a y. But what happens when you take anything times 0? It's 0. So this is really -6 plus 0, or just -6 is a better answer than -6 plus 0i. Make sense? Okay, speed round, just looking at this. It says r equals 8. What shape is it if it's r equals 8? It's a circle, so it's x squared plus y squared equals 64, because you got to square your radius. You're taking two numbers and you're dividing them. Okay, two complex numbers and you're dividing. What do you do with the two radiuses? Divide. So what's 3 divided by 6? A half. Yeah, it's a half. What do I do with my two angles? Subtract 280 minus 350 is -70. What do you do if it's -70? Flip it or add 360 to it. Good. Next one. It's a cardioid. Yeah, just whatever. It's got that's not a big deal. Let's go to the next one. Z to the 5th. So if we're doing z to the 5th here, what do I need to do with the radius? Put it to the 5th power. Okay, whatever it actually says is what you're doing with the radius. The change is with the angle. So it's cosine. What do I do with my angle? Multiply by 5. 5 times 280 plus I sine 5 times 280. Okay, you'd have to subtract out 360 at the end of that. Convert to rectangular form. If we're converting to rectangular form, what two things do we need? X and Y, so you're going to use this formula and this formula. And you're going to plug in. Do this one. So if we are talking about the type of graph, obviously this is a rose. How many petals, Robert, is this one going to have? 3 petals. All right, next thing we're talking about is symmetry. Jochebed, what type of symmetry does this one have? X-axis, why is that? Because it's cosine, it has x-axis symmetry. Last thing we're doing is finding the maximum. So to find maximum, we're plugging in something for cosine of 3 theta. Okay, Sierra, what do we want to plug in there for cosine of 3 theta? +1 or -1? -1. And if we do that, that tells us our maximum is 7. Okay, which is great, but then we struggle with this other part. So we're always used to doing this. We're looking up where is cosine -1. So you go to your unit circle and you look up where cosine is -1. Where is that? 180. Cosine of 3 theta gets you -1 at 180. Okay, but the answer there is 3 theta now is equal to 180. Okay, not just theta, it's 3 theta equals 180. What do I need to do to find my maximum? Divide by 3, so my new maximum is at 60 degrees. Okay, that right there, when it's a rose, you got to take whatever answer you got and divide it by whatever number's in front of theta to help us with our answer. Okay, remember this 360 divided by 3. We divided by 3 because there were 3 petals. That'll tell you you will have a petal every 120 degrees. So you start at 60, add 120 to get 180, add 120 again, your third one would be at 300.